Good evening. So we'll just have a small discussion on what has been done so far in time, speed, distance. Yes, yes. We'll start solving questions. I'll just give you a brief. So in time, speed, distance 1, TSD 1, we covered the relation between speed, time, distance. We covered the conversion between units of kilometer per hour, meter per second. We also discussed the concept of proportionality, three basic proportionalities: speed constant, time and distance are proportional. Time constant, speed is proportional to distance. And the most frequently used, distance constant, speed is inverse of time. We have covered all of this. Then we covered in very much detail the concept of speed average, the general formula. Then we went for distance-based understanding of journey. So based on this, we have covered a lot of examples while I was covering theory, and we have solved 8 questions. Today, most of the questions we will see will be from CAT. Most of these questions are from CAT. I've covered questions till 2019, and 2020 onwards questions I'll be covering in workshops later on. Up to 2019, I've put questions in this sheet. Start. Take a minute or two and solve this. The wheels of bicycles A and B have radii 30 centimeters, 40 centimeters, respectively. While traveling a certain distance, each wheel of A required 5,000 more revolutions than each wheel of B. If cycle B traveled this distance in 45 minutes, then its speed in kilometer per hour is. Make this habit, get into this habit, read everything from the beginning till end without stopping. Once you have read, look at those answer options. They are all multiples of pi. Pi cancel nahi karna hai. You reread, and now when you're reading second time, you start writing down, you start solving. Never start writing down anything in the first attempt of reading. Also, in CAT, I definitely use this approach. Never multiply or divide numbers intermediately. When you're reaching the end, when you're reaching the answer, then finally multiply, divide numbers. नहीं तो sometimes you end up with decimals और फिर आंसर फंबल होता. Never multiply or divide numbers in between. No, the speed is fine at my end. I'm currently looking at the dashboard. It has got stats as well. Let me switch the network if that is the issue. Let me switch the network. Comment answers. So focus on these parts. These two bicycles have wheels of different radius. While traveling a certain distance, when you say Ramesh and Suresh are traveling a certain distance, somebody is traveling a certain distance, they are traveling same distance. So both cycles are traveling same distance. They have wheels of different sizes. The wheel of A required 5,000 more revolutions than wheel of B. And all of this was achieved by B in 45 minutes. So what is the kmph speed? Now imagine that this distance is to be covered. I'm drawing a line here. This distance is to be covered by two cycles. One cycle has a smaller wheel and one cycle has a larger wheel. See, a smaller wheel means it will have to rotate more number of times. A larger wheel means it will have to rotate less number of times for the same distance. Why? One rotation is 2 pi r. So can I say number of revolutions are proportional to inverse of the radii. Larger radii means less revolutions. Lesser radii means more revolutions. So here I directly get a link between number of revolutions of A and B. What is the radius of B? 40. It will come here. What is radius of A? 30. It will come here. Inverse relation. So here what I feel is A is traveling 4 rounds, B will cover that in 3 rounds. So what is the gap? The gap is 1 round, 1 revolution. How much is the total gap between A and B? A travels 5,000 more. I must convert this 1 into 5,000. That means A has covered 20,000 revolutions total and B has traveled 15,000 revolutions total. So I have managed to find out the number of revolutions for A and B. The question is about B only. You don't need to work with value of A. Observe, observe. Here, one revolution is 2 pi r. 2 one revolution is 2 pi r. What is radius? 40 centimeters for B. How many rotations does it go? Revolution does it go? 15,000. Now, this is the distance traveled in centimeters. How much time did the cycle take? It took 45 minutes. What do we need? We need kilometer per hour. We need kilometer per hour. So when centimeter is divided by 100, we get meter. When meter is divided by 1000, we get kilometer. When minute is divided by 60, we get hour. So now I am getting a feel. This is going to be my speed of the cycle. Here, cancel zeros. Do not rearrange pi. Your answer option is in the form of pi. Don't rearrange pi. 3 zeros and 3 zeros are gone. 1 0, 1 0 is gone. If you want to go further, this is 30 cancels 3 times. So numerator looks like to me as pi into 4 into 3. Denominator 15 into 3, 15 into 4. So the denominator will reverse further. Cancel, cancel. Your answer is 16 pi. What you just now solved is a question from CAT from one of the years, either 17 or 18 or 19. 16 pi. This is what I said. Never multiply or divide till the last step. I might want to convert the time into hour and I'm getting 0.75. फिर कौन handle करेगा 0.75? 16 pi. Yes. 16 pi. Two pi r is the distance covered in one revolution of the wheel. 2 pi r. Moving on from this. As it's a CAT question, yes. Try the next problem. Go ahead. A fairly easy question. Very easy question. Try. Not a CAT question. Not a CAT question. No. If CAT level by current standard is 10, this is maybe a level 4, level 5 question at the best. Try. I will complicate it for you. I'll raise the bar. X and Y start running from A to B and immediately return to A. When B has covered 3/4 of the distance between AB, he meets X. When Y has covered 3/4 of the distance between AB, he meets X, who is on his return lap. What is the ratio of speeds of X and Y? This is a 1 minute problem. 1 minute problem. Excuse me. I do not see any answers being commented. So here the locations have been named A and B. People are named X and Y. Y has traveled. What is the task? Go from A to B, reach B, and then return back to A. Immediately turn back or A. So Y has traveled 3/4 of the distance. If I assume the distance to be 4 units, total distance to be 4 units, Y has traveled 3. And what has X done? See, X has gone forward and then turned back. So you look at that red line, look at that white line. If this is 3 units, this must be 1 unit. So 1 unit forward and 1 unit backward. So here if you observe, the total distance traveled by X is 5 units and distance by Y is 3 units when the time is same, because they start together, they keep on traveling. The time is same, distance becomes the speed. So the speed ratio of X and Y is 5/3. The speed ratio of X and Y is 5/3. Now let me raise the bar a little bit. I'm framing 2 questions right now for you based upon this. Observe. Distance, listen to this. Distance of second meeting point from A. Distance of third meeting point from A. Give it a try. In this case, they keep on traveling. A to B, B to A, again to B, again to A. They keep on traveling. So what is the distance based upon what you have done so far? This is the extension of the question. Distance of second meeting point from A and distance of third meeting point from A. So I'll give you a general kind of approach. You can find out the distance of 7th meeting point, 8th meeting point, and so on and so forth. Rarely there have been questions in CAT on 20th meeting point, 13th meeting point. No. Third meeting, 4th meeting, 5th meeting at the best. In circular motion, you can have 1000th meet. It's a cyclic pattern there, not here in linear races. So try. Can you find out how far from A will they meet? You can answer as 2/3 of distance from A, half the distance from A, 2/5 the distance from A. You can answer in form of D, distance from A. So go on, try. How far from A will they meet second time? How far from A will they meet third time? Try. Half of the distance. Very good. Very nice. Next. We can always add level to an easy question in this manner. Let us see. First thing I want you to observe and understand is, after the first meet, where is X heading? X is heading to A. That means X will have to reach A and then turn back. So I'm drawing this line. Look at this line. This is AB. What has X done? I'm using, let us say, green color for A. X started from here. He went to B. He again went to A. Now X is returning. X is returning to the right side. What will Y be doing? Let me use a different color, blue color for Y. What will y be doing? It has reached b and it has turned back. So I want you to count the total number of lines. Total lines, 1 line, 2 line, 3 line, and 4 line. How much total distance has been traveled? Total distance traveled is 4d total. Because x and y have a speed ratio 5/3. X will always travel 5 units, y will always travel 3 units in the same time. So the distance ratio of x and y will always be same, 5/3. So because x is coming from A, I want the measurement from A. I'll focus on x. So 4 multiplied by 5/8. Please pay attention. This much distance has been traveled by x. Total distance traveled by x. So cancelled, cancelled. Total distance traveled is 2.5d. That means he traveled 1d towards B, 1d towards A, and then half. So they meet at the midpoint. That is their second meet. Now, can I say it makes me feel that now I do not know whether y will be returning or will x be returning. I do not know that. In the third meet, we need to be careful and cautious. See, x completes the journey, goes back, completes this journey, and is returning. Let us hope x will meet y after y has returned. So these blue lines are the journey distance or journey length for x. What will y has gone to the side, come back, and is returning. So how many lines? 1, 2, 3, 4, 5, and 6. Total distance is 6d. What is the ratio? 5/3. I want from where? I want the distance from A. So I'll focus on the green line. So distance of y. 6 into 3/8 d is distance of y. I'll just switch off the camera. I think you should not be, or you won't be able to see. So distance traveled by y would be 3, 4. That is 9/4. 9/4 means 1/4. 1/4 of the distance has been traveled by the other fellow when they meet. There is one more method which is slightly intuitive. Moving on from this. Second meet is 1/4. That is correct. First meet is half. That is also correct. Yes, very good. Take your time. Try. two cars traveled same distance starting at 10 a.m. and 11 a.m. respectively on the same day. They reach their common destination at same point of time. If the first car traveled at least 6 hours, then the highest possible percentage by which the speed of second car could exceed the speed of first car. So a deliberate attempt has been made to make this question sound like maxima minima. नहीं जो आप ट्रिक क्रिएट कर रहे हो will not necessarily work. It also depends upon direction of travel क्या है. After fifth or sixth meet, they will both go in same direction. Then this trick will fail. The one you are typing in comment box. Direction of travel is key here. As long as they travel in opposite direction, it will always be plus 2d plus 2d plus 2d. But if they travel in same direction, it will become 3d then. Answer for the current problem. The key giveaway in this question is this part. They are traveling same distance and also they reach the destination at the same point of time. So if I draw a line, this is the distance the cars are traveling. Let us say the car 1 is A and the car 2 is B. This one starts at 10 o'clock. This one starts at 11 o'clock. And they reach here together. Whatever the time is T, they both reach here together. That means the second car gets 1 less hour of journey time. What exactly is the question? Then the highest possible percentage by which the speed of second car could exceed the speed of first car. If I could create for you speed of car 2, what is the name? B, upon speed of car 8. If I could create this for you, percentage increase decrease always happen on something. Car 2 is more than first car. First car is the base. Please observe, because distance is same, speed and time are inverse. In the numerator, I am supposed to write the time of car A, and denominator I am supposed to write time of car B. That is called inverse relation. Speed above B, time below B. Speed below, time above. Now here it says the first car will take minimum 6 hours. So if this is 6, this must be 5. What other possibilities? If this is 7, this must be 6. If this is 8, this must be 7. Must be 1 hour's gap. So here what is the percentage increase? 1 increase on 5. is 20%. The upper car B is 20% faster. Here, what is the percentage increase? 1 on 6. What is 1 on 6 extra? 16.66%. What is 1 on 7 extra? 14.28%. Which is the highest percentage that you see? The highest percentage I see is this one. A CAT question which was answered by a single ratio. A CAT question which was answered by a very simple single ratio. 20%. Speed of second car can be maximum 20% more than the speed of first car. If you keep in mind what is the base, how do we calculate percentage increase, this becomes a two-step problem. Go on, try this. Take 2 minutes. Time is almost up. Comment your answers. Read everything. Always start from first word, go till the last option, non-stop, read again, and then solve. Always. Points A, P, Q, B lie on the same line such that P, Q, B are respectively 100 kilometers, 200 kilometers, 300 kilometers from A. And that's fine. cars 1 and 2 leave A at the same time and move towards B. Simultaneously, car 3 leaves B and moves towards A. Car 3 meets car 1 at Q and car 2 at P. If each car is moving at a uniform speed, then ratio of the speed of car 2 upon car 1 is speed of car 2 upon speed of car 1. This is the question being asked. This is what is being asked to us. Car 2 upon car 1. So in this case, I need to focus on distance because the vehicles are starting together. The time is same. If the time is same, the distance traveled by these cars will represent their speeds. So I have to break down everything in form of distance. How are these points? They are on the same line. P is 100 kilometers, Q is 200 kilometers, and B is 300 kilometers from A. P is 100 kilometers. Now, when you say Q is 200, Q is 200. So you're basically saying Q is 100 kilometers away from P. Same thing. And what about B? B is 300 kilometers. From A, you measure 100, 100, 100. So this becomes B. How is the journey going on? One of the cars 1 and cars 2, they start from A. At the same moment, a car starts 3 from opposite side. Let us go back. Specific part of this. Car 3 meets car 1 at Q. Car 1 has come here, car 3 has come here, and they have just met. See, I want what? I want car 1 in the denominator. In my answer, I want car 1 below. So please observe speed of car 1 and speed of car 3. How much has car 3 traveled? 100 kilometers. How much has car 1 traveled? 200 kilometers. The ratio should be 1 by 2. The ratio should be 1 by 2. Similarly, car 3 meets car 2 at point P. So where do I want car 2 to be? In the numerator? Speed of car 2 upon speed of car 3. How much has car 3 traveled? It has traveled 200 kilometers. How much has car 2 traveled? 100. This 100 kilometers has been traveled. What is the ratio? 1 by 2. Now please observe, in ratios we have seen. You look at this. The denominator is car 1. The numerator is car 2. Multiply both. Speed of car 3 upon speed of car 1. That is the first ratio, 1 by 2. Multiplied with speed of car 2 upon speed of car 3. Again 1 by 2. So car 3 cancelled. Your answer is 1 by 4. What is the learning here? What pattern are we applying? What thought process are we applying? We are saying the time given is same for these cars to travel. So their journey distance should determine their speeds. So all I'm doing is I'm dividing distances traveled. Distances traveled I'm dividing. So answer is 1 by 4. Again, a CAT question from 3 years back, maybe 4 years back. Try. This is not a CAT question, but it is CAT level. And whether you are solving mocks or sectional test or chapter test, you'll come across this question for sure with different numbers because a very conceptual problem. So I'll give you 3 minutes. I'll give you 4 minutes. Solve. Take your time. Start. comment answers. All right. Let me break it down into smaller parts. After traveling 30 minutes, a train met with an accident and was stopped there for 45 minutes. Due to the accident, its speed was reduced by 2 by 3 of its former speed, and the train reached destination 1.5 hour minutes late. 1 hour 30 minutes late. Had the accident occurred 60 kilometers after the point it occurred earlier, the train would have reached 30 minutes earlier. The length of the journey is. I could also ask you, what was the original speed of the train? Both questions are perfectly valid. Any of these questions can be answered with this much information. Please observe. I'm saying the point from where the journey started is A, and everything was okay for 30 minutes time. Not distance, minute, 30 minutes. Here I'm calling this point B. An accident occurs. The train was stationary for 45 minutes. It stopped there for 45 minutes because of the accident. Earlier, the speed, I'm writing at the rate speed. Speed was X. Now I'm not naming this point. You'll see and understand why. The speed is 2 by 3x from there onwards. And what is the delay? 90 minutes. The total delay is 90 minutes. Now, had the accident occurred, it is occurring again, it is happening, the accident happens, but it does not happen at B. It happens 60 kilometers after B. Please observe the difference. The first indication is minutes. The second indication of the fault is kilometers. This is A, this is B. I am naming this point C. Then train proceeds and reaches destination D. So I'm imagining a point C on the track at 60 kilometers from B, just as a comparison. Here, the initial speed is X. Everything is fine till point C. And now the speed becomes 2 by 3x. Now the train reached 30 minutes earlier. As compared to 90, you are arriving early. So you are taking 60 minutes delay. Abhi bhi delay hai. As compared to 90 minutes, you are arriving early by 30 minutes. Now, there's the same assumption that train stopped 45 minutes for repair. So I want you to focus on the journey delay. Don't focus on the stoppage. Focus on journey delay. Can I say 45 minutes was the stoppage time? So journey delay was 45 minutes only. Here, total delay is 60 minutes. 45 minutes was the stoppage delay. So journey delay is only 15 minutes. I wanted to perform a comparison. Why is this happening? Can I say here, this part of the journey, 60 kilometers, and this part of the journey, 60 kilometers. That is the only difference. The speed is low and the speed is high. You see the first part, the speed is same, time is same. The last part, CD distance, I do not know how much that is, but the speed is same. The only difference between the two outcomes is between BC. In first case, the journey is 60 kilometers with a speed of 2 by 3x. Second case, the journey is 60 kilometers with the speed of x. Because of this higher speed, you manage to save half an hour. Distance upon speed is the time. And the gap between time is half an hour. What is the saving here? There's a 30 minute saving here. So if you solve this, you take out 60 common. You take out x common, so it becomes 3 by 2 minus 1 is equal to 1 by 2. And you solve this. You will have x is equal to 60 kmph. So you can answer for the speed of the train. Speed is 60 kilometers per hour. So if you travel 60 kilometer ka speed for half an hour, how far will you go? 30 kilometers. So first part I converted into distance. Now I need to focus on CD. Now I can do this with long equations and formulas, but I wanted to apply common sense. What common sense? I am traveling same distance C to D. I am traveling at a slower and a faster speed. I can apply this formula and see how much is the saving time here? 50 minutes. I will save only 15 minutes. Now let me speak about this. By traveling 60 kilometer faster, I was able to save 30 minutes. What is the delay from here onward? What is the delay? Delay is 15 minutes. I want to save those 15 minutes. Can I say if I want to save 15 minutes, I should travel faster for 30 kilometers? This must be 30 kilometers. So I'm answering this to proportions. I'm saying to be able to save 30 minutes, you have to drive fast for 60 kilometers. I don't want any delay in the second example. What is the travel delay? 15 minutes. I don't want that. So to save 15 minutes, I must travel for 30 kilometers at a higher speed. So the last lap is 30 kilometers. Total is 30, 60, 30, 120 kilometers. You can answer for speed. Speed in this case is 60 kilometers per hour. And distance in this case is 120 kilometers. So this translates into a question on comparison, based on comparison. Confirm that you're done with this. No, we are not saving 30 kilometers. What we are saying is, see, I am not trying to solve one more equation. It will become lengthy. I'm saying when the train traveled 60 kilometers on a higher speed, by traveling on a higher speed, how much saving was done? 30 minutes. Why is there 15-minute ka delay? Because train is traveling slower. For what part? For the last part. I'm saying if you want to save 15 minutes of time, you should travel faster for 30 kilometers. If you travel faster for 30 kilometers, you will be able to save 15 minutes. That is the question here. Moving on. Shall try this. It is again replica of the previous question we solved, or 3 by 5, 5 by 3 question we solved earlier. It's a replica of that. Go on, take 2 minutes. Let me check the network. So very straightforward question. I mean, you should get the answer in 2 steps. Two swimmers start from the same end A of a 200-meter long swimming pool. The faster one reaches end B, turns back, and meets the slower one at a distance of 150 meters from starting point. Where will the slower one be when the faster one reaches starting point? So the distance between the 2 points A and B is 200 meters. Very straightforward question. Let us say the faster one is X, slower one is Y. So the faster one meets slower one at a distance of 150 meters from starting. So here, this person has gone, turned back, and this person is meeting Y, where 150 meters from the starting point. Let us call this point C. The question is, where is the slower one when the faster one reaches starting point? So from here, you have already got the speed ratio. Distance traveled by X is 250. Distance traveled by Y is 150. The speed ratio is 5 by 3. I want to know when X has reached here. X has reached here. Where is Y? So X has to travel how many meters further? 150. If X travels 150, that is 30 times, how much will Y travel? Y will travel 30 meters into 3, 90 meters. So that means, see, how much was the distance in front of Y? Y was looking at 50-meter distance. So Y will complete that distance. Y will complete that distance 50 and further travel 40. So where is Y? Y is 160 meters from here. Because all the hints are from the starting point. All the hints are from the starting end. All of them are from starting end. So Y is 160 meters from starting end, or A. Y is 160 meters from A. Moving on. Again, a very simple question. Answer it verbally, not even CAT level, maybe CET SNAP level. You can answer it almost verbally. Go on, try. What is Bikram doing? I think I'm getting your chat messages delayed by a minute or so. I'll cover that one more time. Don't worry. I'll cover that one more time. Not an issue. Bikram covers the first half of the distance between Pune and Mumbai at 45 kmph and rest at 55 kmph. What is the distance between Pune and Mumbai if he took 4 hours to reach Mumbai? Simply, when somebody divides the journey in equal distances. See, he divides journey in equal halves. Equal halves. In that case, the speed average becomes twice of A into B upon A plus B. We have talked about this. So that looks like to me as 2 into 45 into 55 upon 100. Never multiply or divide, never multiply or divide until final step. What does it say? The journey took 4 hours. If I know the average speed is this, if I multiply average speed with the total time, I will have the distance. What is that? 4 hours multiplied by average speed upon 100. So 5 into 9, 5 into 11, 5 into 20, again further 5, 4, 4 and 4 cancelled. So 18 into 11, 198 kilometers distance between Pune and Mumbai. Always solve through harmonic mean. This way of writing is called harmonic mean. When do we apply this? When the distances are equal between 2 points. In this question, what was being said is, in this question you were saying that the distance between A and B, that is the pool, is 200 meters. The faster one reaches B and turns back to meet slower one at a distance of 150 meters from the starting end. What is the starting end? Starting end is A. So if I call them X and Y, X has reached B and is turning back. How far has Y traveled? Y has traveled 150 meters from A. I'm calling this point C. So what is the speed ratio here? This person has traveled, Y has traveled 150 meters. In that same time, distance traveled by X is 250. So speed ratio is 5/3. Question 13 you want to cover? Yeah, we'll go back to that as well. Yeah, yes. So now the question is, when X reaches here, where is Y? So what is the distance X has to travel further? X has to travel 150 meters. So Y will have to travel 90 meters. That would mean Y has covered these 50 meters and turned back 40. So how far is Y from the starting end? Y is 160 meters from the starting end. That is the question. Where is Y? Now, here, what was the question? The question was find the distance between the 2 points or total distance of journey. See, here, focus on this part. I can do it with equation also if you want. When 60 kilometers were traveled at a faster speed of X as compared to slower speed of 2/3x, what was the saving in time? 30 minutes was the saving. When you travel 60 kilometers faster, you save 30 minutes. Now see, I'm doing what here? I'm saying here in the second case, there is a 15-minute delay. Why is that delay? You are traveling slowly. I don't know what is the distance. The distance is small d. You're traveling slowly over this journey. If you travel faster, you will not be delayed. So I do not know what this distance is. I want to save a delay of 15 minutes. I want to rather recover 15 minutes, recover. 30 minutes recovery needs 60 minutes of faster travel, faster travel. Here, why is there delay? Because you're traveling slow. If you travel faster, will you recover that? Yes. So you want 15 minutes ka recovery. Because the recovery is half, the journey distance must also be half. This will be 30 kilometers. That was the trick. And you will definitely find this question in mocks. You'll definitely find this question in chapter test, sectional test, whatever material you solve. थोड़ा डेविएशन होगा, 60 किलोमीटर की जगह कुछ और होगा, 2/3 might be something different. Moving forward. So try the question 16th. This is a question based upon average speed, but you will notice this does not fit the standard criteria of equal distance or equal time. But in ratios, I have taught you something. When you have to deal with such language, half of it was taken, then from the remaining 1/3 was taken, and from remaining 1/4. Whenever there's a continuous chain like this, from the remaining, multiply denominators and assume. It will save you a lot of calculation time. A journey across Bombay, a tourist bus averages 30 kilometers or 10 kilometers per hour for one-fifth of the distance, 30 kilometers per hour for 75% of the rest of the distance, 20 kilometers per hour for the remainder. What is the average speed? So what I heard here is I'm going to divide distance by 5. Whatever remains, 75 percentage kids is 3 by 4. I will multiply 3 by 4 with the remaining distance. And then finally, whatever remains will be the leftover distance. So here I want you guys to observe. I am dividing the distance by 5 and 4. So I would like it very much if distance was a multiple of 20. Multiply 5 and 4. That's it. Multiply them. Furthermore, I have a speed of 10, 30, and 20. Understand? In the formula, if you remember, this is how we write average speed. Total distance upon total time. We divide this by speed 1, speed 2, and speed 3. If you remember, you don't have to write down the formula in the exam, but apply that thought process. I'm going to divide this by speed. Speed is 10, speed is 20, speed is 30. So what is the multiple of 10, 20, 30? The multiple of 10, 20, 30 is 60. So here I am assuming 60 kilometers as the distance. So you can assume any number, will not matter, any number. 60 kilometers, I've assumed that 60 kilometers. What is 1 by 5 of 60? फिर 10 से डिवाइड नहीं होगा ना. टेक अ लार्जर नंबर. लेट अस टेक 600. क्या फर्क पड़ता है, कौन से पैसे लगेंगे? टेक 600. So 600 kilometers are traveled. 600 kilometers total are traveled. Total. What is 1 by 5 of this? 1 by 5 is 120. How much remains? How much remains? Remaining is 480. This 120 kilometer is on the speed of 10. From the remaining we calculate 75%. 75%, 3 by 4. Cancel 120. So how much remains? 360. At how much speed? 20 kmph. What remains now? 120 kilometers further remain. What speed? What average speed? This is 30. This is 30 ka speed for the middle part and 20 ka speed for the ending. ये आपका average speed आ गया. Numerator is 600. Denominator is 12 plus 12 plus 6. So 600 upon 30. So 20 kmph is the average speed. 20 kmph is the average speed. By assuming a good value for distance, you were able to save a lot of calculation time. Moving on from here. Try this. This is the CAT question. Uses the concept of average speed. If I'm not mistaken, 2018 CAT. Go on, try. Yes, yes, this is fine. You have to simply account for the distance travel total. But LCM LCM लंबा पड़ जाएगा ना इसमें. You take distance as 5 units or 4 units तो. So here you offer, you here observe, one can use three different transports which move at 10, 20, and 30 kmph respectively to reach from A to B. Amal took each mode of transport one third of the total journey time. Slow down. Amal is dividing the journey in three intervals of time, while Bimal took each mode of transport one third of the total distance. Bimal is dividing the journey in three equal distances. Three equal distances. The percentage by which Bimal's travel time exceeds Amal's travel time is, because they are both going from the same starting point to the same end point, their their distances are same. So the speed and time are inverse. Be very careful. The percentage by which Bimal's time is exceeding Amal. So what I want is time for Bimal upon time for Amal. What will this translate into? This will be inverse of speed of Amal upon speed of Bimal. What will be the speed of Amal? Because Amal is dividing journey in equal times. So speed of Amal will be 10 plus 20 plus 30 upon 3, which is 20 kmph. The numerator will be 20. Time of Bimal upon time of Amal is equal to 20 upon. What will be speed for Bimal? Do you guys remember formula for three values? 3 into A, B, C divided by A into B, B into C, C into A. So you see the numerator has a very large number. 2 into 3, 6, 6 into 3, 18, 18,000. What does denominator have to offer? 2 plus 6, 8 plus 3, 11, 1100. Two zeros cancel. So 180 by 11 is the speed of Bimal. Where will that speed go? In the denominator. Never multiply or divide unnecessarily. This will go above. So it becomes 11 and this cancels 9 times. 11 by 9 is equal to time of Bimal, time of Amal. So how much more do you see? I see here 2 units more on 9. 2 on 9 is 22.22 percentage more. What was the question? By what percentage is the time of Bimal more than Amal or Amal? In this case, we need Bimal to have the numerator time and Amal to have denominator time. So their speeds will be inverse. Confirmation on this problem? Try this. This is a question from those years when exam used to be paper based. You could flip pages, you could start with any section, you could solve any section as much as you like. In those days, again, CAT has gone back to same difficulty level, same, I'll say, cutoffs. You solve 8 questions, 8 questions, 8 questions correctly, you get all calls. And these were the only IIMs back then. Blackie. Profile of file, then there was no need for 10th, 12th, 90 marks, 90%, and so on and so forth. So questions used to be huge like this. On a single rail, only a single rail track exists between stations A and B on a railway line. 1 hour after the northbound superfast train N leaves station A for B, a southbound passenger train S reaches station A from B. The speed of superfast train is twice that of normal express train E, while speed of passenger train S is half of E. On a particular day, N leaves for station B from station A 20 minutes behind the schedule. To maintain the schedule, both N and S increase their speeds. If superfast train doubles its speed, what should be the ratio approximately of the speed of passenger train to that of superfast train so that S reaches exactly at scheduled time on that day? So again, as I said, this is a very, very old question, maybe of the year 2006 or 7 or 8, ancient question. You will find 2 to 3 methods for solving this. But the best one is time. You focus on the value of time, you'll get your answer very fast. Speed average gives you decimals. Calculating exact speed gives decimal. Don't do that. Observe. What? Forget north, south, east, west. There is a station A, there's a station B. There is only one railway track. If there is a train from A, until it reaches B, there can be no train from B. That is the idea of a single track exists between A and B. 1 hour after northbound superfast train leaves station A. After a superfast, I'm calling SF superfast train, it leaves A. After 1 hour, there is a passenger train. There is a passenger train that reaches here. That tells me the total time taken by superfast and total time taken by passenger is 60 minutes. In 60 minutes, this train has to leave B, and in that same 60 minutes time, total 60 minutes time, the passenger train has to leave A. They have to cross. First, this train will leave A, it will reach B, and then after that, this train will leave B, it will cross A, reach A in total 60 minutes time. That is what it means up to this point. Forget northbound, southbound, eastbound. The speed of the superfast train is double of the speed of an express train. And speed of the passenger train is half of the superfast train, express train. Passenger train S is half of E. Superfast train is twice of E. That gives me idea. The speed of superfast train and speed of passenger train are 4:1. इसका speed 4 गुना तो इसका speed 1. Now you remember the speed ratio is inverse of time. Speed ratio is inverse of time. That means the time of superfast train and the time of passenger train is 1:4. If you divide 60 minutes, that tells me the superfast train takes 15 minutes to complete the journey. The passenger train takes 1/5. 5. This is 12 minutes. 12 minutes. Takes 12 minutes to complete the journey. And this one, 4 times of that will take 48 minutes to complete the journey. Are we on the same page so far? अभी तक समझ रहा है आपने को? This clear to everyone? Chalo. Now, the second part. On a particular day, this train starts 20 minutes late. Because this train starts 20 minutes late, whatever you have to do, go forward and then send other train, you must achieve it in 40 minutes. And the train starts 20 minutes late and it has what? It has doubled its own speed. It has what? It has doubled its own speed. To maintain the schedule, both N and S increase their speed. Super fast train doubles. If you double the speed of super fast train, the new time of super fast train will be 6 minutes. Earlier it was 12 minutes, you double it will become 6 minutes. So how much time does the other train have? 34 minutes. The question is, can you find the speed ratio? Please listen to this. Speed of passenger upon speed of superfast would be time of superfast upon time of passenger. Inverse ratio, which is pretty much 1 by 6. Which is 1 by 6. That's your answer. And you observe in the entire question, you do not have to deal with any decimals. If you convert this into average speed, there's a method in which we try to find average speed of both trains combined. Then second case, we find average speed of both trains combined. Then we find the difference in average speed and then we find the ratio. You'll keep on dealing with decimals. Speed से इसको मत solve करना, you will get stuck. Super fast train speed has been doubled. Because speed has been doubled, the time will become half. The time taken for the passenger train would be 34 minutes. Why 34 minutes? Already 20 minutes delay से गाड़ियां चालू हुई हैं. 20 minute delay से गाड़ियां start हुई हैं. So remaining 40 minutes, the complete journey must be covered. Good. Moving on. Let us try one more question and then we'll call it a day. Do we have more questions? Yeah, why not? Let's complete these. On a 20-kilometer tunnel connecting two cities A and B, there are 3 gutters. The distance between gutter 1 and gutter 2 is half the distance between gutter 2 and gutter 3. The distance from city A to the nearest gutter 1 is equal distance of city B from gutter 3. On a particular day, hospital in city A receives information that an accident has happened at third gutter. The victim can be saved only if the operation is started within 40 minutes. An ambulance started from city A at 30 kilometers per hour and crossed first gutter after 5 minutes. If driver doubled the speed of the after that, what is the maximum time the doctors would get to attend the patient hospital? Assume 1 minute is lapsed from taking the patient into and out of the ambulance. So go on. A lot of information. This is what is happening in CAT now also. There is so much information that you have to first look for the key points. Look for those areas where you get some extra hints. So here the first hurdle that you face is to locate these, I'll say, gutters. If I say city is A, there is city B here. There are three gutters: gutter 1, gutter 2, gutter 3. Some hints have been given to us, like distance between gutter 1 and 2 is half of the distance between gutter 2 and 3. I'm using ratios here. If this is 2, this shall be 1. Distance between gutters 1 and 2 is half of the distance between 2 and 3. So this is 2, this is 1. The distance between city to the nearest gutter, gutter 1, this distance is equal to this distance, gutter 3 and city B. On a particular day, there's a hospital here. That hospital has received some news that there's an accident where here there is somebody probably dying or lying here at gutter 3. So ambulance has to go pick up that person and bring back that person, and it says operation must start within 40 minutes. Once the phone rings here, it must be done within 40 minutes from that. So how does the ambulance travel? The ambulance travels from city A at 30 kmph. 30 kmph means, please understand, 30 kmph means it will take you 2 minutes to cover 1 kilometer. The vehicle crosses first gutter in 5 minutes. It's a very important hint for me. It took 5 minutes for this gutter to be crossed. Please observe. 2 minutes is 1 kilometer. 30 kmph means 2 minutes is 1 kilometer. That means 5 minutes means 2.5 kilometer. This is 2.5 kilometers. That would also mean this is 2.5 kilometers. So total distance being 20 kilometers, 2.5 is 5 kilometers, means this is 15 kilometers. This is 15 kilometers. That means this is 10 and this is 5. Applying the understanding of ratios, I need the ratios to be 1 by 2. I want 15 to be divided as 1 by 2. So 5 kilometers and 10 kilometers. So right now 2.5 minutes are gone. The ambulance is here. Now what does the driver do? The driver doubles the speed from here on. When the speed gets doubled, जब speed double हो जाता है 60 kmph, it means 1 minute is equal to 1 kilometer. That means this has to go 15 kilometers forward, 15 minute, and it has to go back. It has to go back 17.5 kilometers, means 17.5 minutes. And it takes what? It takes 1 minute of getting the patient into the ambulance and getting out. Total 1 minute. In total 1 minute, in assume 1 minute, is lapsed from taking the patient into and out of the ambulance. So 1 minute total. So total time 2.5 minutes plus 15, 17.5, 17.5, 17.5, 35, 35 plus 1, 36. Total 36 minutes have passed. And what is the time duration? 40 minutes. So can I say 4 minutes are available? Just recheck my calculations. 4 minutes are available for the doctors to check the patient. ए बाबा 5 मिनट था ना, ये 2.5 मिनट थोड़े थे, तो मिनट तो 5 था ना. सो ये 2.5 से बढ़ेगा बेटा, यू विल हैव 38.5 मिनट्स. देखो फिर से कैलकुलेट करो. 5 मिनट है, 5 मिनट्स, 15 मिनट्स, 20 मिनट्स, 20 मिनट्स एंड 17, तो 37.5 मिनट्स, 37.5 मिनट्स. एक और मिनट था उनका जाने आने का. So 38.5 minutes have gone, total 38.5. So how much time will the doctors have to look at the patient before the operation starts? 1.5 minutes. This was your problem. How much time will the doctors get with the patient or will get to treat the patient before operation? 1.5 minutes. It's a very elaborate problem when it comes to the language. It's a very elaborate problem, but you look at the calculation part, it's very small. You convert those hints into minutes, you convert first minutes into kilometers. Once you do that, you convert 60 kmph again into minutes into kilometers, plus minus. नहीं, +1 भी आएगा ना. देखो, this is 5 minutes, plus 50 minutes plus 17.5. ये वापस तो पूरा जाएंगे ना सिटी ए तक, 60 की स्पीड से पूरा वापस जाएंगे. सो फ्रॉम हियर हाउ मेनी किलोमीटर्स आ जाए? 17.5 प्लस 15 प्लस 5. और 1 मिनट क्या था उनका? व्हाट वाज दैट 1 मिनट फॉर? वो पेशेंट को एम्बुलेंस में डालना एंड टेकिंग आउट द पेशेंट फ्रॉम द एम्बुलेंस. टोटल टाइम टेकन इज 38.5. 5 minutes plus 15 plus 17.5 plus 1, 38.5 minutes. So try this. Very simple question. A motorbike leaves A at 1 p.m, moves toward point B at a uniform speed. A car leaves B at 2 p.m, moves towards A at a uniform speed, which is double the speed of motorbike. They meet at 3:40 p.m. at a point 168 kilometers from A. What is the distance in kilometers between A and B? If I am not mistaken, this is a question from 2017 CAT. A very easy question nonetheless, but from CAT. What are the points? Points are A and B. At 1 p.m, what is happening? A motorbike moves towards B. I'm calling the bike, let us say B. At 2 p.m, what is happening? At 2 p.m, the car starts from here. The car starts from here at 2 p.m. And motorbike, let us say, has a speed of x. The car has a speed of 2x. When do they meet? They meet at 3:40. At what distance? 168 kilometers from A. So from 1 o'clock to 3:40. See, I'll prefer to convert this into minutes क्योंकि decimal आ जाएगा नहीं तो. From 1 o'clock to 2 o'clock, 60 minutes. 2 o'clock to 3 o'clock, 60 minutes plus 40. So 100 minutes have passed. In 100 minutes, how much distance has been traveled? 168 kilometers. So that gives me idea. For every minute, the distance traveled is 1.68 kilometers. Don't convert in speed. Nahi chahiye apne ko, don't worry. Now, because the speed of the other vehicle is double, can I say in 1 minute, the other vehicle will travel double of this? 6, 3, carried over 1, 2. 2.36 kilometers will be traveled in every minute. So from 2 p.m. onwards, 2 p.m. to 3 p.m. 60 minutes. ये क्या कर दिया मैंने, कैल्शियम मिस्टेक करी बड़ी ब्लंडर वाली. Silly mistakes will cost us, guys. Be careful. 1 o'clock to 2 o'clock 60, 2 o'clock to 3 o'clock 60, that is 120, 120 plus 6, 120 plus 40. So 160 minutes are gone. तो ऐसा डेसिमल लाने से अच्छा ऐसा लिख लो, you can say 1 minute is equal to 168 upon 160. That is the kilometers for every minute. So speed on this side will be 236 upon 160 kilometers for every minute. इसको मिल रहे हैं 100 मिनट जर्नी के. 100 मिनट तो 100 मल्टीप्लाई कर दो, कितना दूर गए होंगे, 100 मल्टीप्लाई कर दो ना, कैंसिल. This is 20 into 5. This is 20 into 8. Can I cancel this with 8 directly? Is it possible? Is it a multiple of 8? Integer में आंसर तो होना चाहिए, होना पड़ेगा इसको. So 4 से कर लो, 4 into 2. 4 into 59 by 2. चेक करो क्या आंसर आ रहा है. Distance between A and B. Yes. So इसको रीएडजस्ट कर लो. 2 into 168, 2 into 168 divided by 160 into 100. 210. This is 210. बेटा 100 मिनट का जर्नी है ना इसका. How many minutes is this one traveling? 2 बजे से 3:40, 100 minute. So 210 kilometers. कैलकुलेशन का चेक कर लो. 20 into 5, 20 into 8, 236 by 8 into 5. 336. Yes, 210 exactly. 336. 210 kilometers. Total is this. इसको रिलेटिव स्पीड से बना सकते हैं, बट नो नीड. टाइम पास होगा, टाइम वेस्ट होगा. डोंट गो फॉर रिलेटिव स्पीड राइट नाउ. कल के लेक्चर में वी विल कवर रिलेटिव स्पीड्स. That's it. That's the end of the session. That was the last problem we had. Yeah, great.